Students, welcome to my channel cbse Maths Class 11 Sets Exercise. We have complete 1.3 exercise and now next theory Venn diagram. Venn diagrams. Okay. Today we start Venn diagrams, operations of sets, union of sets, and their examples. Before we start, I want to say you those who are new, click the link given in the description box and get the previous classes one by one. This is the only channel for you to go through only CBSE NCERT book page by page. Theory and example and exercise. If it is useful to you, like it and subscribe it to get the classes up to date. Let's start today's class. Hello. Venn diagrams. Slowly and clearly, line by line, follow my class to get clear conceptions. Most of the relationships between sets can be represented by means of diagrams, most important, which are known as Venn diagrams. Venn diagrams are named after the English logician John Venn, 1834 1888. These diagrams consist of rectangles and closed curves, usually circles. The universal set is represented usually via rectangle and its subsets by circles. Okay, here is the rectangle, it is U universal 1 2 3 4 5 6 7 8 9 10. Okay, and here is circle, it is subset. There are 2 4 6 8 4 8 10. In Venn diagrams, the elements of the sets are written in the respective circles, figure 1.2 and next 1.3. Here is also a rectangle and two circles. So there are two subsets, isn't it? Illustration 1, figure number 1.2, universal subset, universal diagram sets which are elements are 1 2 3 4 5 6 7 and 10. Just before I say that it is universal and there are the elements of 1 2 3 4 5 6 7 8 9 10. All the elements are in the universal, and that is U. In the universal set, which A is A means here is A 2 4 6 8 10. Understood? It's a subset of this universal set U. Now next, illustration 2, here is 1.3. Now let's see. 1.3, U is 1 2 3 4 5 6 7 8 9 10. Okay, is the universal set of which A is 2 4 6 8 2 4 6 8 10. Okay, and V 4 6, only V 4 6. So these are the subsets of the universal sets. Okay, the reader will see an extensive use of Venn diagrams when we discuss the union, intersection, and difference of sets. Now, slowly we can enter the Venn diagrams. Okay. Now let's operations of sets. In the earlier classes, we have learned how to perform the operations of addition, subtraction, multiplication, and division of numbers. Okay. Each of these operations are performed on a pair of numbers to get another numbers. For example, when we perform the operations of addition, a pair of numbers 5 and 13, okay, we get the number is addition 1 8 18. Again, performing operation multiplication of the pair of numbers 5 and 13, we get 65. Similarly, there are some operations which are performed on two sets give rise to another set. Yes, as like as the numbers, we multiply, we add, subtraction, maybe. So we'll now define certain operational sets and examine their properties. Hence, we will refer all the sets as subsets of some universal set. Okay, students, union of sets. Now let's see that let A and B any two subsets. Okay, A and B. A, here is it is A and B. Suppose. So the union of AB is a set of consists of elements of A and all the elements of B. The common elements being taken only once. Yes. Let's the example. Let's A elements are 2, 4, 6, 8. And B is 6, 8, 10, 12. So union A and B, what will be? 2, 4, 6, 8. And here is repeated 6, 8. It is not taken. Okay. Now 10, 12. So union of AB is 2, 4, 6, 8, 10, 12. Clear? Note that the common element 6, 8 have been taken only once while writing AB. Clear? So here is, you know that the union, when we union the two sets, the common elements are taken only once. Okay. Now, example 13. Let's A is equal to AEIOU and B is equal to AIU. So, AB equal to AEIOU because AIU are taken only once and previously we have taken it. That is why B is equal to AEIOU and is equal to A because A is equal to it. So we can prove that AB union is equal to A. Okay. Now example illustrates that the union of sets A and its subsets B is the set of A itself. So that is why we can write that B subset of A and then AB subset is equal to A. Clear? If you don't understand the clear conception of this chapter, please comment on it and I will again describe it. Solution. We have solution here is example 14. Let's A X is the set of Ram, Gita, Akbar be the set of students of class 11, okay, who are in school hockey team. Ram, Gita and Akbar, team X. And let Y, Gita, David, Ashok be the set students from the class 11 who are in the school football team. Okay, now find X union Y. So X union Y, Ram, Gita, Akbar, it is common. Then we find out which is common. That is taken only once. Gita is once taken. That is Gita is not taken another. So Ram, Gita, Akbar, Gita already taken. Dravid also. So XY union is Ram, Gita, Akbar, Dravid also. This is the set of students class 11 who are in the hockey team and on the football team or both. Clear? Very simple. Not very difficult if you understood line by line and follow my class. Okay, students? Now, thus, we can define the union of two sets as follows. Here is the diagram, and it's a rectangle and two circles A and B. The union of two sets A and B and set C, which consist of all those elements, all those elements which are either in A and B, including these which are in both. The in symbols we write A union B, that is a set where X is such that X belongs to A or X belongs to B. The union of two sets can be represented as Venn diagram as shown in the figure 1.4. It is Venn diagram. The shape is 1.4. Union AB is a Venn diagram. Here is A, and the common place it's A. So, some properties of operations of union. A union B, B union A, commutative law. Yes. A union B is equal to B union A. And A union B, C is equal to A, B is equal to C. If C is equal to A, that is B and C also union. Suppose A and B are one union, okay? And C is equal to A. Here is C is equal to A. So that is B and C are also union. Next, A and phi is equal to A union phi is equal to A. That is why the law of identity element phi is the identity of. So, and next 4, A union A is equal to A in idempotent law. And U union A is equal to U law of. So students, today we 1.3 Venn diagrams, and Venn diagrams means two sets are in common and there are subsets, that is it is a rectangle and it universal sets 1, 5, 3, 7, 9, and in this set it is A subset 2, 4, 6, 8, 10. So that is, it is rectangle and all the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and here is the A is the subset of the universal set. So elements are 2, 4, 6, 8. It's Venn diagram. Understood? And next operations of sets. That means union of sets. Union of sets. Let's A is equal to 2, 4, 6, 8 and B is equal to 6, 8, 10, 12. Okay, so A union B is equal to, what is it? 2, 4, the first is written 2, 4, 6, have to read, and next 6, 8 are common and these taken only once and it is common, so it is taken, already taken, that is the left 10 and 12. So it is the union of AB. Understood? Here's the gist of this chapter. And now next, some properties. It is very important. Some properties. Students follow it. Number one, A union B is equal to B union A. Okay. Here is A is and B is. So AB are 2, 4, 6, 8, 10, 12. So AB is, and B union A is, it is B. It is B. So we write it. We write B union A is equal to, first of all we write 6, 8, 10, 12, and now then all are written and common are 2, 6, 8, 2, 4, 4, 2. So AB union is equal to BA. Okay, the first one. And second one, AB C is equal to ABC. And number three, A phi is equal to A. It is law of identity element, and phi is the identity of. Okay. Number four, A union A is equal to A. Okay. And number 5, UA union is equal to U. Law universal. Law of U. So students, today the last, and next day we'll meet again. If you understood better and like it, and subscribe it to get the up to date classes day to day. Okay, bye bye.